It's working. Yes. Okay.
That was
Great.
so late.
Um,
And then I started joking.
I don't know which one is better.
Don't be quiet.
Okay, guys. So, Skylar, have a seat.
Linear
Do
system.
you have your notes out? I need you to take good notes, okay? Jackson. All right, so as we've figured out and discovered, solving systems of equations by graphing is not always easy, right? It's complicated sometimes. So there are algebraic methods. There are two methods. One's called substitution, the other's called elimination. There's actually more than those two, but these are the two that we're going to learn this year. And the substitution is the one we're going to learn first. And it's really quite simple. What does substitute mean?
Like switch it out for, kind of.
Switch it out for it. Does that make sense to you guys? You've heard that term before?
Like
right?
use instead of.
Like in basketball, there's like a bench with substitute players. So like,
Yeah.
if like someone gets injured or someone
Right.
needs like rather than you can like substitute.
It's like the backup.
So I'm going to give you this. I'm going to write two equations here. All right. Now, by the way, I just want to make one other comment. Sometimes systems of equations are also called linear systems. Linear means straight lines. Systems means a bunch of straight lines, right? Right? So linear systems the same as systems of equations. Every now and then, some textbooks will use the concept or the name of simultaneous equations, which actually is my favorite one, but very few people use it. But it means two equations simultaneously on the graph together. Where do they cross, right? I like that. But I don't see it very often. So when you're doing substitution, you have to remember when you have a point, right? Like let's do it over here. When you have a point, when you have a line here, this is 1, 2, 3, and sure, we'll do it here. Let's say you have a point right here where they both connect, right? And so this point is true for this line. You guys with me? This point is true for this line. It's on this line. And it's also on this line, right? Do you agree with me that the y of this point is the same for this line as the y is for this line? Well, what's the point? 3 comma 0. It's 3 comma 0, right? The y is 0 for this line, and the y is 0 for this line, right? Yeah. So the y is equal each other. You agree with me? And the x's equal each other. So technically, I should be able to interchange y's from either equation. Kind of interesting. So think about it. Think about it. I know the y is the same for the solution. I know the y is the same for both of these. So if that's the case, so listen, if that's the case, what if so Jackson, you're talking nonstop. Put that away and leave it there, okay? Yeah. I have 4 minutes, just so you know, to teach this lesson. So that's why I need you to be quiet.
I can't see the numbers. Thank you.
All right. Since I know the y's are going to be the same, I could say, well, instead of having two equations, could I combine these equations in some cool way? Right now, I have two unknowns here in this equation. You agree with me? I have two unknowns in this equation. I have a y and an x. What if I said, but in this one, I know that y is equal to 2x. So why not circle what y is equal to and replace the other y with what y is equal to? If y is equal to 2x, then I could put the 2x in the place of the y. I could substitute this 2x in place of this y. Does that make sense? And let's see what that does, though. Let's see why that's so cool. So now I'm going to write it, 2x. Now that instead of writing this y, I know this y is this y. It equals 2x. Therefore, I'm going to write 2x instead of y equals x plus 5. Does everybody understand what I just did?
Yeah, but that doesn't equal.
Does everybody understand what I just did?
Yeah.
It does equal. That's what that says. It says 2x is
I know,
equal
but it
to x
doesn't.
plus 5.
If x
Just
was 5.
bear with me for a second. All right, that's an equation. It says 2x does equal x plus 5. Therefore, what did I just do that's so awesome? How many variables do you have in here now?
1.
Right, one variable. If you have one equation with one variable, you can solve for that variable. Always. One equation with one variable you can always solve for. So let's do it. All right.
X equals g.
I'm going to subtract my x. I want my x's on the same side. You with me? And then suddenly 2 x's, take away 1x, I have 1x, right? Is equal to, these cross out, is 5. Wow. That's awesome. I know that my point has an x of 5. Am I done?
No,
What do I also need?
You figure out y. So by
I have to figure out my y. So how would I figure out my y?
what happened to the 2? So you have
I have 2 x's.
You
I
subtract
subtracted 1x. There's a hidden 1 right there.
Oh, okay.
Right?
And then you.
So I subtracted 1x. I got rid of this x from this side. So now I have 1x is equal to 5.
What happened to the y's? Oh, wait,
Now, to find the y's, all I have to do is substitute my 5 in the place of x in either of these two equations. It doesn't matter. Whichever one you want. I could try this one. Y is equal to 2 times 5, right? I could do that. Y is equal to 2 times 5, which means y is equal to 10. Or I could have used this one. Y is equal to 5 plus 5. 5 plus 5, y is equal to 10. So I know x is 5, y is 10. You with me?
No. Yes. I don't understand. Why would you do x equals 2 times 5? Why would you do that?
I didn't put x.
Sorry, y equals 2 times 5.
Oh.
Why would you do that?
Because I found out what x is.
Yeah.
But I need to know what y is. So I take this information, I now don't know that x is
Oh, sorry.
5. And I bring it
yeah,
back up to
never mind.
these. You see what I mean?
Yeah,
And you just plug it
because
in.
x is
It's a good
5.
question,
Yeah. never
right?
mind.
But
Yeah,
you
I
have
got
to
it.
remember, when you're solving for systems of equations, you're looking for a point. And that point, it has to have, so, are you writing notes?
No.
Where are your notes? Dude, what are you doing? This is a lecture, right? You got to watch this and take notes tonight, okay? And I have to see the notes tomorrow. It's really important you take notes. You're not going to know how to do any of this if you don't take notes, right? You have to take notes. So you're looking for that point, and that point is an x comma y. So you have to have an x and you have to have a y. So you could either have your answer like this, x is 5 and y is 10, that's totally legal, or you could write it as a coordinate. A coordinate would be the x comma y, right? In parentheses. So it would be 5 comma 10,
Which would you prefer on the board?
and I put that in a box.
And we get a decimal?
It doesn't matter. You know, sometimes when you're dealing with graphs, this is kind of useful.
But there won't be any
But
graph.
sometimes you're doing systems of equations where you're actually looking for, you know, the cost of gum versus a toothpick, right? And so, you know, your gum is 5 cents and your toothpick is 10 cents or something like that. So then it might not be quite as useful this way. It might be more useful to write it this way. But it doesn't matter. This is totally legal. Either one is totally legal
Will we get
for solving
decimals on
systems
our
of equations.
board?
Not on this one, no.
Okay.
So the key is, with substitution, you have to have something that says y equals, okay? And you find what y is equal, you circle it, and you substitute it into the other y. And then suddenly you have no y's left over. You have no y's here.
Can you try another one real quick?
Yes.
Gary, I have a question.
Yes.
Will the problem be set up like this with 2 problems above each other on the homework?
Yes. Yes. They will all be set up like that. Maybe you're not going to find it, I don't think, too hard. Here we go. What if I did one that's slightly harder? All right, what if I did, okay. so this one is 2x plus y equals 5.
Wait, what?
2x plus y equals 5.
Oh, I already did that in my head.
And y is equal to x minus 4.
X plus y equals 5. Stop pressuring me,
Okay.
Barry.
So now, everybody write that down?
Yes.
Okay, so let's look at it. Which one says y equals?
Well, one, the bottom.
The bottom one. And y equals this, right? I'm going to circle. And guys, do not use shortcuts by not circling. Trust me, I'm teaching you this for a reason. Circle what y equals. And then put an arrow to the other y. Then you know exactly what to do every time.
Oh.
Right? So suddenly I know I've got to rewrite this, except for instead of that y, I'm going to put what y equals. So I'm going to write 2x plus, instead of y, I'm going to put x minus 4, what I circled. X minus 4 and equals 5. Don't take shortcuts. Just do exactly this method. And it will always work and you'll always know what to do. All right, what is 2x plus x?
3x.
3x minus 4 equals 5. Add 4 to both sides. I've got 3x is equal to 9. Right? Divide by 3. X is equal to 3. Look at that. I know my x. Now to find my y, I go to the one that says y equals. Because it's so easy.
So
X is 3 minus 4. What's 3 minus 4? Negative 1. So y is negative 1.
And then
Y
your top one.
Is equal to negative 1.
And then it's
And I'm done.
3.
Or you could say 3 comma negative 1 in parentheses.
So
and put
which
it-
one do you want us to write on?
Either one you want.
Either one.
Either one. Either one. Does that make sense? You get it?
Kind of. Hope so. Think so.
Just remember to circle what y equals and put an arrow to the other y. And then you'll be fine. Okay? That's it.